6.6 is properties of definite integrals. We'll go over the properties and then we'll apply them. So the first property, if you're taking the integral from a to a of f of x dx, since you're taking the area from where you started to where you ended is the same, this is going to be 0. Okay, if you take the integral from b to a of f of x dx, that's the same as the going backwards, so it's going to be the negative integral of a to b f of x dx. So if you switch the lower and upper bounds, you switch the sign. If you take the integral from a to b of a constant times f of x, you can do the integral from a to b and multiply your result by the constant. If you're taking the integral from a to c and from c to b of a continuous, this is the same as finding the area from all the way from a to b of f of x dx, because you're just adding up the two areas. If you're doing the integral from a to b of f of x plus or minus g of x, you can do each one individually and then add or subtract the results, and you'll get the same answer. Okay, so let's look at when we might use these properties. Okay, so example 1 is going to be a graphical example. Okay, so for part A, let's take the integral from 0 to 12 of f of x dx. So 0 to 12 is just the area under the curve from 0 all the way until 12. So pretty much the whole thing. So what is this? This is a circle, semicircle. The center is 2, so the radius is 2, so this is pi 2 squared. 4 pi, but it's half the circle, so it's divided by 2, so it's going to be 2 pi. Should I write that down? What is that? Pi r squared, pi times 2 squared, 2 pi. This is a trapezoid, so that trapezoid is 1/2. The height is 2. The bases are 4 and 1, so 4 plus 1. What is that? 5 times 2 is 10. Half of 10 is 5, so 2 pi plus 5. And then this last piece is a triangle. The triangle is below the x-axis, so I'm going to subtract the results of the triangle, but the triangle is 1/2. What's the base? 4. The height is 2, so that's 4, so I'm going to subtract 4. So the integral from 0 to 12 of f of x dx is 2 pi plus 1. It's a positive result, which looks correct, because it does look more positive. Okay, now, if I want the integral from 12 to 0 of f of x dx, that's the same as doing the opposite sign of 0 to 12 f of x dx. Okay, so instead of redoing the whole thing, I'm just going to change the signs. So I know the answer from 0 to 12 is 2 pi plus 1, so this is going to be negative 2 pi plus 1, or distribute the negatives and get negative 2 pi minus 1. Okay, and you don't have to show the work for it. You can just write negative 2 pi minus 1 because you're going backwards, you're changing the signs. Okay, if I'm doing the integral from 7 to 6 of f of x dx, the lower limit is normally lower. So normally we calculate it using a lower limit that's lower. So I want to swap them. If I swap them, I have to change the sign. So I'm going to change this to negative 6 to 7 f of x dx. Okay, so now it's going to be negative, the integral, not the area. The area under the curve from 6 to 7 is just here. What is that, 2? It's just 2. So this is going to be negative 2. Okay, and then for D, the integral from 12 to 8, so that's backwards, plus it has this weird 3 in the front. So how I could rewrite this is I could say I want to switch the boundary, so I'm going to make it negative. I'm going to multiply the result by the 3. So I switch the boundaries. And then I'm just going to do negative 3 times the area under the curve from 8 to 12. 8 to 12 is here, which was that triangle, which was 4, but it was below, so it was negative 4. So the answer is 12. And you don't need to show this algebraic setup at the beginning, unless it asks you to justify your answer. Okay, example 2 is the same idea. We're going to use the properties to evaluate the integrals, and they're going to give me given information, which is going to be useful, or it might not be useful enough, and I'm going to say there's not enough information. Okay, so the first one is I want the integral from 5 to 1 of f of x dx. Do they give me 5 to 1? 5, no. They give me 1 to 5, though. Right, they give me the integral from 1 to 5 of f of x dx. I want the integral from 5 to 1. Okay, so the algebraic setup is, I would say, this is the same as negative 1 to 5 f of x dx. Which is negative, and then what was the answer for this? This was negative 3. So negative 3, which is just 3. And I wouldn't necessarily show that algebraic setup. I'm showing for your notes. Okay, so for b, it's the integral from negative 2 to 5 of f of x dx. What do we have? I have negative 2 to 1. That's not negative 2 to 5. I have 1 to 5 of f of x dx, and this is g of x. Okay, I don't have from negative 2 to 5, but I do have negative 2 to 1, and I have from 1 to 5. So if I go from negative 2 to 1 and I go from 1 to 5, I should be able to get from negative 2 to 5. So this is the same as if I went from negative 2 to 1, added up the area, and then went from 1 to 5. That should be the area from negative 2 to 5. So that this is going to be, what is this? 4 plus negative 3, which is 1. And if it didn't ask me to algebraically show my work, I would probably just say 4 plus negative 3 is 1, or something like that. So do show a step, but you don't have to necessarily show the algebra work. Okay, negative 2 to 1 of f of x plus 2 g of x dx. Okay, do I know negative 2 to 1 of f of x? I do. So algebraically, I'm going to show you the setup, although I would not show this step. I'm going to show it to you for your notes. Okay, so for negative 2 to 1, f of x dx, I know the answer to that. That is 4. Okay, now for 2 times g of x from negative 2 to 1, do I know that? Well, I know negative 2 to 1 of g of x. I don't know the 2. So I'm going to put the 2 on the outside. So I'm going to do plus 2 times the integral from negative 2 to 1 of g of x dx is 8, so this is going to have 2 times 8. So this is 4 plus 16, which is 20. And again, I would not show the algebraic step at first, but do show this step so I can see where the values are coming from. Okay, let's try another one. D from 0 to 1 of f of x dx. Okay, 0 to 1. I have negative 2 to 1. I have 1 to 5. Is there any way I can get from 0 to 1? Negative 2 to 1. If I knew negative 2 to 0, I could figure it out. I don't think I have enough information. So for this one, I believe I do not have enough information. There is an answer. I just don't know the answer based on the information they gave me. Let's try the next one. Okay, so from 1 to negative 2 of 3 times f of x dx. I have negative 2 to 1. I don't have 1 to negative 2. Now I'm going to skip the algebraic step because I'm going to show you what I would actually probably show. Okay, I do negative 2 to 1. This is 1 to negative 2, so I'm going to switch the signs. So that's going to be a negative. I have this weird 3 here, so let me put a 3 here. And then the integral from negative 2 to 1 f of x dx answer was 4. So I would say that this is negative 3 times 4. And the answer is just negative 12. If you would like to show the algebraic step, that's fine too. I'm just saying you don't have to. Okay, for f, the integral from 5 to 5 of f of x minus g of x dx. As long as those functions are defined, this is automatically going to be 0, so I'm not even going to look at the information given. Okay, example 3, piecewise defined function. The function g is defined by g of x equals 3 for x is less than 2, equals 4 minus x for x is greater or equal to 2. Find the area under the curve from negative 1 to 5 of g of x dx. So I'm going to do this graphically, and as a side note, I'm going to show you how I would put it in a calculator, even though we haven't worked with calculators much with this, just because I want you to know. Okay, so let's graph this. So g of x equals 3, so y equals 3 is the horizontal line for x is less than 2. So at 2, so this is the horizontal line. X is less than 2 is the open circle. Okay, g of x is the line 4 minus x. Line 4 minus x is the y-intercept of 4. It goes down this way. For x is greater or equal to 2. So I'm going to plug in 2. 4 minus 2 is 2. So this graph starts at 2, 2. The slope is negative 1, so it's going to go this way. Okay, so I want the area under the curve from negative 1 pi over 2 here. Does that look okay? Okay, let's just find the area here. What is this? This is going to be, let's start with this little piece. I'm not worried about the open circle. I just want the area to curve. That's 3 by 3. So what is that? 9? 9 plus, what's this little triangle? 1/2, 2 by 2 plus 2 minus that baby triangle, which is like 1/2. So 9 plus 2, 11 minus half is going to be 10.5. Okay, now you're going to do this by drawing, but I just want to show you graphically what I would do. If I were doing this, not graphically, in my calculator. In my calculator, if I want the area from -1, it's a piecewise, so at -1 to 2, I'm going to use this function. And then from 2 to 5, I'm switching to the other function. Okay, and then once I learn how to calculate that algebraically, I might do this algebraically, or I could use my calculator, which we'll practice using our calculator more. Okay, let's look at b. b is what is the value of the integral from 0 to 5 of the absolute value of x minus 2 dx. Here, I'm going to graph this. Absolute value makes a v. The transformation is it goes to the right 2. So right 2, and it's going to make a v shape. Okay, what do I want? The area to curve from 0 to 5. So 0 to 5. So what is this going to be? This little triangle is 1/2, 2 by 2, so that's 2. Plus the other triangle is 1/2, 3 by 3, so 4.5. It's going to be about 6.5. No, it is 6.5. Okay, now we're not going to be able to ever integrate absolute values, so you could put this in your calculator to verify your answer, and it would work. Okay, let's look at example 4. Example 4 asks, what is the difference between the absolute value of a to b f of x dx and the integral from a to b of the absolute value of f of x dx? And when you put them in the calculator, your calculator can interpret the difference between the two, but you don't always have your calculator, so you need to be able to interpret the difference. Okay, so let's do each version so you can see what the answer ends up being. So if I want the absolute value of the integral from -2 to 4, I'm going to absolute value the results. So the integral from -2 to 4. Okay, so what's the area here? This is a circle with a radius of 1. So what is that? Pi r squared divided by 2. So that's -pi over 2 because it's below the x-axis. What about this one? This one's also pi r squared divided by 2. So plus pi over 2. Plus that triangle, which is 1/2, 2 by 2. So it's 2. Okay, and then I'm going to absolute value the result. Okay, so I'm going to absolute value 0 plus 2, which is 2. So for this first one, I get an answer of 2. So the absolute value of the integral from -2 to 4 of f of x dx equals 2. Okay, so for b, we're going to do the integral from -2 to 4 of the absolute value of f of x dx. If you are absolute valuing the actual function, you're making all the pieces positive. Okay, so I'm going to change the actual function and then calculate it. Okay, so now I'm absolute valuing the function, which means this curve that is below the x-axis, when I absolute value it, all the y values end up above the y-axis. Okay, so actually this piece ends up being positive pi over 2. Plus, this is already above the axis, so plus another pi over 2. Plus that triangle is 2. Okay, so now my answer is going to be pi over 2 plus pi over 2, which is pi plus 2. So it's not the same thing when you absolute the function versus the result of the function. Okay, example 5 is a calculator question. Go ahead and try them on your calculator. Check your answer with the notes posted on Canvas.